All right, welcome back, Science 7. Today we are continuing our Unit C, heat energy. So last time we learned about heat because heat energy is one of those unique form of energy that has a certain directionality. It always moves from hot object to cooler object. Fancy one that explained that is called thermodynamics law. But long story short, heat energy has a certain direction, and that happened not only on Earth but also any place on this universe. Last time I asked you about the homework about doing and completing science log activity number 3, which is about explain why your body warms up near the campfire and write down step by step and indicate the direction of heat movement. So we're going to go over that as a first. If you haven't, this is a good part where you need to pause or hit a pause button and go through each of those. If you're already finished, go through. And if there's something that you haven't put, please write these down. The first thing that happened is logs combust. That means burns. Then you have a heat energy coming from fire. The first step, logs combust, and that means it's burning. While we have a burning going on, heat energy is released by the combustion. The combustion. There you go. And number 3, heat energy. For some reason, the typing is really not good. Heat energy, in this case, radiation. And we're going to learn about the different form. Radiation is how our body get hit when it comes to campfire. Heat energy, vibrate air molecules. An example is oxygen, nitrogen, etc., etc. So third step, heat energy basically warms up the air molecule and air molecules in contact with our body. And last part, body temperature goes up. This is a little bit of a steps to answer your science log activity number 3. Logs burn, and from that, heat energy is released, and heat energy in the form of radiation vibrate the air molecule and make the air molecule go up and down. That's the one that you see like a little mirage around the campfire. An air molecule warms up with a contact with our body, and our body temperature goes up because of that. This is really detailed step by step. Today our focus is how humans start using heat. So we're gonna go very long ago situation, which is Stone Age, and Stone Age are known to be about probably more, about 7,000 BC. This era is known as Paleolithic time. Simply speaking, Stone Age, we didn't even use any type of metal during that time. The source of the heat energy was woods, like the one that you see down there, like campfire. Energy path to bring out this heat is, first of all, chemical energy from the woods is the source of energy because we're burning any type of carbon inside and chemicals that has a potential energy, we're burning that. And 2, so where that energy turning into? It turning into heat energy via combustion. And this is used to warm up the cave, cook raw meat. So human has used the heat energy simply by combustion for such a long time. When it comes to Paleolithic era, as you may notice, inside of the cave we burn our woods and logs and branches to create some kind of heat source that is used for cooking and so on. So during I'm just going to go back. During this time, the one of those members of the family, their job is keep the fire going on and on and on. Because if the fire is going off, then it was really, really tough to make a fire. That's why. And it is actually quite challenging if you tried. So how did humans use heat? Now let's go to a Roman era. As you may notice, it is now going into like boiler situation. Ancient Romans, they developed something called central heating system, which is what we use in modern era too. But central heating system work like this. You have a certain heat source, which is available on one corner of the house or room in that case. The source is of course wood. They didn't know how to use coal and others too. But we are controlling the energy path to dissipate and go into the house rather than going outside of the house. So heat is going around the house, and that's how the house is warm. The energy path from source of energy, as you may know, is chemical energy from wood. Then some of you may wonder what's the energy format afterward? It's heat energy via combustion. And as you may notice, we have a floor. So underneath the floor, the heat energy will go around, and then that will be good enough of heat to warm up the surface of the whole floor. Plus, it can go on and travel upward through the inside of the wall. So as you may notice, the wall can also be heated up, which means we have multiple heating going on in a single room, in this case, house, if you will. It is used to warm up the house. And we are using modernized central heating system, except we are using heated water sometimes too. We know that, and some of you guys, if you use the basement, this is a boiler. The boiler is the one that use, how can I say, it has a heating source. Like the word says, it boils the water. So let's look at each of the system. We have a boiler underneath, let's say basement. Then the water will be heated up and vapor will travel too. Some of them go to what I like to call radiator. If you go to an old hotel or motel, you will see radiator. Those are the one that produces heat. And the water can also go around and then store as a heated water over here or cool water so that you can use any hot water, cold water depends on. So it does not only go through the pipe like what the one that you see to produce any type of heat directly to the rooms, but also it can produce heat energy to warm up the water so that we can use warm water anytime. Let me explain how our country did. It's very similar as a central system. In Korea, this is how we heat the floor. This part is not be on the test, by the way, but as you may notice, we have kitchen. This one that you see over here is the big pot, the one that makes soups and rice, those kind of thing. And we have our heat source over here, which is burning woods. And what we did is instead of going through the whole area of the house, we are actually built in terms of the way that we don't have a basement, but from the first floor, we have a little gap so the heat can travel. So let's look at the heat situation. First thing first, in the kitchen area, these are hot area. So that means if you think about the energy path of uh, therm- thermal energy or your heat energy, if you will, heat energy always go from hot to cool area. The opposite side is obviously a little bit cooler. So in ancient not ancient, so old South Korean houses, or North Korea too, in fact, they build kitchen always at the corner. Because if that happened, or opposite side, the heat energy will go around, and then as you may notice, these are stone, these are not wood, so it's not gonna be burned. The stone will be heated up, and those heated stone will actually warm up each of the room directly because we know that heat energies always go from hot to cold, and as you may know, when it comes to this room, that's relatively colder area, so the heating system start from the floor, not through the wall, or we are not heating up the um, air system like how modern Canadian houses work. And the last part that you see in here is chimney. So you know the heat energy go through, and then a lot of toxic gas like carbon monoxide, the one that give a poisonous effect, they're gonna go out. So we do use central heating system, except ours are way more focused on the floor. So, which system is more efficient? Well, I want you to highlight this. Heated air always travel vertically upward. So, if you are thinking about floor heating system, the heat energy will always start from the bottom and it's going to go upward like that. On the other hand, when it comes to Canadian system, radiator heating, radiator is the one that warm up the air, and then warm air will travel up along the wall and then cooler air going down. So it actually contradict to each other. Will it be efficient for some? A lot of studies says this is starting to get more inefficient as time go, because the good thing is it circulate the air, but it makes your skin very dry too. Just for the heads up. And cool air comes down, so certain areas hot, certain areas colder. On the other hand, if it's floor heating, it's evenly get heated up. So that's why people try to use mixed method. Cool air, I want you to highlight, always go downward. To be fair, ladies and gentlemen, cool air and cool water, anything that is colder, they're heavier. What about Europe? So this is 1200 AD. So how does human use heat? As you may notice, we have a big hint over here, chimney. We European invented chimney system, literally at the roof or even taller than the roof. And they start combining chimney with the stoves, and they use what I like to call similar to central heating system, but it's more multi-purpose. Stove and chimney can be worked together. And later, this chimney is built into the walls of the building. As you may notice, this is a building on the left side, and then chimney is on the right side. So there is a complete separations happening. And when it comes to stove, this is an ancient stove. It does use wood. There were a certain period of time that people used other chemical source like coals and all, but it turned out to be very not inefficient, but it's very dangerous. So people move away from it. But chemical energy from the woods, heat energy via combustion, but chimneys invented, please write down and highlight carbon monoxide gas, which is very toxic to human. And it used to cook and warm up the houses. Now, let's put more to modern era, even though it's around 1800s. So think about a beginning of industrialization. As you may notice, there are lots of health problem. I mean, look at the air over here. the quality of the air condition, that's not good because these are the one that is not only for toxic to human, but also it speed up a lot of ecosystem problem like acidification of rain, lake, acid snow, everything is affected by it. And it also plays a huge role for global warming process too. But let's go through how human use. First of all, central heating system use a little different source when it comes to 1800 and in future. Nowadays we use natural gas. We don't even use diesel as much because of the pollutants. But back then, source was coal. And when it comes to coal, there's a dangerous chemical that is abundant. I want you to put sulfur. Sulfur. Sulfur content is quite high in coal. So if it's burned, it's actually more toxic energy, toxic chemicals coming out than the other stuff. Energy path, regardless of what kind of dangerous one, let's go through from the let's see the beginning energy. Coal used dead ferns from million years ago. So it's actually like imagine a remain of fossils of million years ago ferns, the one that is in the dinosaur era. And those ferns have a lot of sulfur in it. So no wonder why coal has a lot of sulfur contents. And then once it becomes combined with oxygen, it becomes sulfur dioxide. That becomes a deadliest acid that I can think of, sulfuric acid, which is like battery acid. Imagine you're inhaling those, even though it's not in acid form yet. Heat energy is what's going to happen afterward via combustion. So most of the heat energy that human has been using was involved burning. The problem with the combustion of coal, this is where things are getting quite serious. Coal ash has a lot of deadly chemical too, like mercury and lead. But when it comes to combustion of coal, some of the air pollutant, carbon dioxide. Some people say, Mr. King, carbon dioxide is important because CO2 gas is used for photosynthesis. You're right, but excess amount is not good because it can create something called carbonic acid. Nitrogen dioxide, which is known as NO2 gas. Sulfur dioxide, this one is deadly. It's SO2 gas. And these gas molecules speed up the greenhouse effect and acidification of rain. Today, I'm going to put a pause button for my lesson and I want you to work on the homework question that I'm going to assign right after this.